Okay, minor arc. So less than 180, less than half the circle, 2 letters. So one option's DE. What's the other option? DC. If you put this as the answer, you got partial credit. Do you know what I'm missing? The arc symbol. So you have to have the symbol so that we know it's an arc. Number 2, what's a major arc? More than 180. How many letters? 3. So has to start with E. You could do EDC or ECD. Did we miss any? ECS. ESD. Yep. Had to start with E. Anything else that we missed? Okay, put a star on it. Okay, name a semicircle that contains point E. So semicircles are exactly 180. How many letters do you use? 3. So what are your choices? DES. You could also have the reverse SED. Again, if anything's wrong, just star it in your other color. ESD would go like this. See how it's more than 180? Okay, name a radius. Oh, go ahead. E. No, because that would be this whole thing, EDS. Okay, name a radius. There's a bunch. DP, PS, I see one more. PC. If you had the reverse, PD, SP, CP, that's fine. A diameter. What's the diameter? PE, there's no segment. DS, yep, or you could have it backwards, SD. EC doesn't go through the center, so it can't be a diameter. What is the name of the circle? Circle P. What is a tangent? It is RT. Does anybody know like what a tangent is though?
It's outside the circle.
It is outside the circle, not 2 spots, 1. Touches in exactly 1 spot. So you can see RT touches the circle at S. S is the point of tangency. It's where it touches the circle. What's a chord? 2 spots. It's going to touch the circle at 2 spots, but it stays in the circle. So DE is an option. There's more. EC is an option. There's actually one more. DS. The diameter actually is a chord. What is a central angle? Yeah, so it's an angle that's formed at the center of the circle. Angle 4 would be an option. Angle 6 would be an option. I won't take if you just say angle P because there's lots of angle P's. So I would say like DPC. You could name it that way. You could name it SPC or CPS. Tristan? Nope, letters are good still. What did you name it? Okay, so I owe you a point. DPC is an okay answer. Any other ones you have questions on? Xander? Just put a little star. Wait, if you get it wrong, you can write the correct answer, just do it in a different color. Please. Okay, the next one, 11. Name an inscribed angle shown. DEC. Yes, I would take that. So this angle. DEC. Angle. Okay, angle 9 I don't think works because do you see, like, here's angle 9. See how it doesn't go all the way out? But it doesn't. So it's not considered an inscribed angle. It has to have, all the points have to be on the circle. Angle 8 is one. Anything else? Justin? Yeah, so give yourself a little star. Anything else? Here? No. All the endpoints of the angle have to be on the circle. So if it was like this, then yes, I would take angle 9.
Does DC or does DSE work?
DSE, nope, because there's no, if there was a segment here, then yes, you could do DSE. But like, do you guys see what I'm saying about the endpoints? See here, here's all the endpoints. If that was it, yes. Each point has to be on the circle. Anything else about those? What's the measure of angle 2? 90. So this is a tangent. It's meeting a radius. That makes this 90 degrees. Questions on 1 through 12? Yes. Yeah. Okay, 13. 13 is an inscribed angle. What do you know about the relationship between the angle and the arc? It's double. The arc is 2 times bigger, so this should be 46 degrees. This next one I had wrong on my answer key, so a lot of people probably got it marked wrong. This is a central angle, so what do you know about the angle and the arc? They're the same. And I accidentally had it wrong on my answer key, so I probably owe a lot of people that point back. So if that's you, star it. Sorry about that. I had 42. I won't take your point back if I messed it up. You got a freebie if I'd messed it up. But I would write down the correct answer so you know that this is the correct answer. Yes. So far, everything has been worth 1 point. Okay, this one down here, I started with these two. What do you know about those two angles? They're both 65 because they're vertical. Then up here, how many degrees is this whole arc right here? 180. So you can find this missing part in the middle because you have 65 and 40, which all together is 105. If you subtract from 180, you're going to get 75 degrees. How can you find TC then? Yeah, do the same thing. So 180, what should I be adding together though? 70 and 65, so that's 135, which gets me 45 for right here. Are you okay with filling in the missing angles? Then you just have to read. So it says angle RPE. That's this angle, RPE. We said it's 75. Angle SPC. SPC, that's this one, that's 65. And then these were arcs. So again, my computer wouldn't let me add those in. But TC is this one. So that's 45. And then for RDE, you start at R, go to D, all the way to E. So it's this whole purple one. Brightly. They're the same. Yep. So how can you guys find this purple arc? How did you get that? Okay, you could add each one of these sections, or you can take 360 minus, you don't need 75. Either way, you're getting the same answer. What did you say? 285. Perfect. Questions on any of those on the front? Those were each worth 1. Okay, next page. The first two, 16 and 17, people did pretty well. So you are just plugging in the radius or whatever they give you. So the radius here is 7. So C equals 2 pi 7. 2 times 7 is 14. So you could put 14 pi, or some people typed pi in the calculator, and I think you got 43.98, which if you want to round, could be 44. The second one, however, they give you the diameter. So what's the radius? 9. Then you can plug it in, 2 pi 9. That gets you 18 pi. Did anyone type it in the calculator? I think it's 56. 60, sorry. 56.55. Okay. So that would be it if you typed it in around it. This line was good, but this line wasn't. No, I think I just crossed it off. The next one is where things got tricky for people. So these ones, they give you the circumference. So if you write out your formula, we are plugging in for C. So right here, 16 pi goes here, and then you solve for R. How do you solve for R? Yeah, divide by 2 pi. Okay, when you do that, a bunch of stuff cancels. So pi's cancel, 2's cancel, pi's cancel. 16 divided by 2 is 8. It asks for the diameter. That's the radius. So double it and you get 16. So if you had radius but didn't have diameter, I think I took off half a point. Ask you that in a little bit. Yes. Yeah. Right, because there's no solving for the top two. I feel like I'm being really generous today, not giving you some progress books, so can we not nitpick my grading? So what does that say? 8? Like what's after that? I think I'm trying to okay, because I thought it said 8 pi, that's why I took it off. Yes. Right, I didn't grade work on this because you can type it into your calculator. You're not getting your things back, so you can I can take off 2 more for the top 2 that would feel better. Okay, this one is for sure where people got real messed up. And I kept seeing the same mistake over and over and over. So again, you plug in the circumference where C is in the formula and it looks like this. I'm going to do this one in 2 steps to show you where people are going wrong. The answer I got a lot was 9 pi. I'm going to show you why it's not 9 pi. So I'm going to start by just dividing by 2. Can you see how I could do that, right? Divide both sides by 2. That cancels out my 2's here. That leaves me with 18 divided by 2, which is 9. Are you guys still good? And then I still have pi times radius here. Now what would you do? Divide by pi. That cancels out these pi's. What is your radius? 9 divided by pi. It's not 9 pi, it's 9 divided by pi. That is the radius. You can type it into a calculator, and I think it's like 2.2 9. Yep. Unless it specifies, well, this actually, sorry, this says round to the nearest 10th. So we should have had 2.9. Yep. I didn't read my own directions. And then this was another commonly missed one. So what people are not, a lot of people put 90 degrees for the answer here. This arc is 90 degrees. That's true. But when I ask for arc length, you're imagining like you're eating a pizza. Can you see how this would be the piece of crust? It's like I'm asking you, how long is that piece of crust? You're going to give me an answer that's in inches, not degrees. It's inches. Like if you took a measuring tape and measured it. So how could you find the circumference of this entire circle? Yeah, 2 pi 5. 2 times 5 is 10, so this is 10 pi. Are you okay with that? 10 pi is the length all the way around. I don't want all the way around. How much do I want? 1/4 of it. So you take 1/4 and you multiply it by the whole thing. So you're either going to have 2.5 pi, and then I think the decimal is like 7 point. Did anyone put the decimal? 7.86. It is. So then I would owe 1. What is it, Mark? 7.86. Let me see the other part. Sorry, I was doing these real fast last night. Because I don't have your fraction. That was the only part. But I really only should have taken off the half now that I think about it. So put like a star over here and let them check that. No, you're good. Put a little star. Okay. Down here, on 21, your answer had to be yes or no. So you got a point if you guessed correctly, which a lot of people just guessed. The correct answer is no. What this is asking is, if this was a tangent line, that would mean that this is a 90-degree angle. So we're really asking ourselves, is that a right angle? And the way you test it out is doing Pythagorean theorem. How long is that whole side right there? 6. So you're going to test it out. You're going to do 3 squared plus 4 squared. And you're asking yourself, does it truly equal 6 squared? And when you do it, you get 9 plus 16 equals 36. Is this true? No. So the answer is no, it's not tangent. Yes. The next one, I think people just forgot what to do. So this is like, I don't know, I call it like the ice cream cones. So up here, see how these two tangents meet at the same point outside the circle? Yes. So they're the same length. They're both 13. And then it happens again here. These two meet outside the circle. They have to be the same length. How could you find that part right there? 25 yeah, 25 minus 13. So this is 12, which makes this 12. How could you find this part here? Subtract 12 from 21.8. Help. 9.8. If this is 9.8, this is 9.8. And then again over here, 4.6, 4.6. To get perimeter, you're just going around and adding all the numbers together, and I think it's 78.8. Was that correct? Yeah. For 23, you've got these tangent lines meeting a radius, and that makes 90-degree angles. How many degrees do quadrilaterals have to add up to be total? Yeah, 360. So I have 90, 90, and 100, which all together is 280, making your missing angle 80 degrees. Are you guys still okay? 90 plus 90 is at 180, plus 100 is 280. Down here, you have to do Pythagorean theorem. So one thing I know is that these two segments are the same length. So this is 10.6. Because when a tangent line meets a radius, it's 90 degrees. No, because that's 100. Squares have 4 90-degree angles. Okay, so those two have to be the same, and then to find your missing segment, you can just do Pythagorean theorem. Just a reminder, C is always across from your right angle, so it looks like 10.6 squared plus 4.3 squared equals x squared. What do you get when you square and add it together? 103, 130 point something? Thanks. When you take the square root, I believe you get 11.4. Anybody? Okay. 25 was worth 3 points. There's a lot going on here. So the first thing is, the goal of these is to have a right triangle so that you can do Pythagorean theorem. Right here, this is a radii, and you can draw a radii in anywhere. They're always going to be the same length. So if I come over here and draw in a radius, can you see how it would also be 18.9 long? Then the only thing I can find right now is this piece here, so I went ahead and called that y. And I started by solving for y. So it would be y squared plus 15.7 squared equals 18.9 squared. And when you solve, I believe you get 10.5. Did anybody do that? 10.5. However, when you get 10.5, that is just this red piece, and I want this blue piece, so it turned out purple. Here we go. So what is this whole segment altogether? Yeah, it's another radius, so it's 18.9. So if I take the 18.9 and take out that red piece, I can't do my colors today, that red piece, I'll be left with just that little blue section, which is 8.4. So you got 1 point for setting this up, 1 point for this answer, 1 point for your subtracting, just if you're trying to keep track of where your points are. Okay, the next page was this guy. I'm not really going to go over the process because I'm not putting it on the test tomorrow, but you should have gotten R being 7, and then you should have got C being 14 pi. I'm sorry, I can't remember what that is, like, as a decimal. But I probably took that. Centimeters.
Oh, I did it.
Yeah. Yeah, I took half a point off if you were more than 0.5 away. Okay, last page. These are about inscribed angles for the first one. So the first thing you need is this arc DB. How could you find that? Yeah, so 79 and 40 added together is at 119. Sorry, my math is not.
Yes.
Okay, and then the whole circle should be 360. So when we subtract, we get 241. So that's this arc. However, the arc is not what you want. You want the angle that's attached to the arc. So what do you do to that number? Not subtract. Divide by 2, so 102.5. 120.5. Just kidding, can't math. For the next one, to find x, you have to use the cyclic quadrilateral information. So how do you find angle C? Or, yeah, angle C. Yeah, opposite angles have to add up to be 180. So we're taking 180 and we're subtracting 128, and you get 52. Then for this arc right here, AB, if you try to highlight it, there's no angle attached to it. However, there is an angle attached to AC. So how many degrees would AC be? But how do you know that? How do you know it's 78? Yeah, you take 39 and you double it. Then if the whole thing from A to C is 78, how do you get AB? Yeah, subtract out the 40 and you get 38. Bless you. Any other questions? I'm not going to do the bonus. I don't want to.